General circulation of Earth. We can separate the general circulations into three different blocks: the polar cell, the Ferrel cell, which is also called the mid-latitude cell, and then the Hadley cell, and then the Hadley cell, Ferrel cell, polar cell. On the picture on the left, you can kind of see where how the circulations in each ones go. So the moist air kind of hits each other, rolls over into dry air. And then the picture on the right one is just saying how the two blues create a lot of moisture in the air, so then it rains a lot. So a lot of this happens during, like, at the equator line in the tropics. Here is a simpler example. So in the north, the polar cell moves south to the warm air, and then the warm air is moving north toward the cold air. And then both of these Hadley cells move to meet each other. Continuing down, the Ferrel cell moves down toward the polar cell, and then the polar cell moves up toward the Ferrel cell. The Coriolis effect pushes air to curve. Because of this, we get wind from in the north to kind of move to the right, and in the southern hemisphere, it kind of moves to the left. This just kind of shows you the different weather that each cell block gets. So at the equator, this is where the warm air rises, it cools, and then it rains. And this is why at the equator you have a lot of tropic environments, and it's also pretty humid in those areas. That air continues to go north where it is cold, and then at the next block it sinks, and then it warms back up again. And then this air is very hot and dry, which creates a lot of desert environments. From there, the air goes south, and then it goes north with a right curve. The air that moves north rises and collects moisture, and this also leads to a lot of rain, and then sometimes a lot of snow, like places in Canada and Alaska.